Hello everyone, welcome to the My Learning tutorial. Today we are going to discuss about what is time complexity. Time complexity, okay, and why interviewer asked time complexity and space complexity. Different types of time complexity and space complexity, and rules to calculate time complexity. Okay, so what do you think? What is time complexity? So generally, what we understand that time taken to run the code. Is it correct? Let's assume there are a person named A who have MacBook. Okay, person A have MacBook and person B have a 10-year-old laptop like Dell. Okay, so is there any difference between MacBook and Dell? Yeah, there is a difference between MacBook and Dell. In 10 years ago and in 1 year's old MacBook. Okay, so there is a difference between CPU and processor, and you know that our code is going to run based on this also. Okay, so think that MacBook takes time to run 100 line of code in 1 second. For 200 line of code it takes 2 seconds. Okay, and for 500 line of code it takes only 5 seconds. Okay, for 1 second, 2 seconds, and for 5 seconds. Yeah, okay, and for B, like Dell takes for 100 line of code, it let's assume it takes 2 seconds. For 200 line of code it takes 4 seconds. Okay, so for 500 line of code it will take uh, like uh, 10 seconds. Okay, so what is time complexity is? This is not the time complexity. Time complexity is this theta, rate of increase. So time taken to run the code is not time complexity. So what is the time complexity? So rate of increase in times with respect to input side, respect to input size. Okay, so this is the time complexity. And how we denote time complexity? We denote time complexity in using big O notation. Don't worry, we will discuss further what is big O notation. So here, and what is this? Your time taken. Okay, so let's discuss within a code. Like here, for I in range print okay. Okay, so what basically is this code will do, first understand that uh, first I will take value 1. Okay, I equals to 1. Then what next happen? It checks that is I is less than 6 or not. If yes, then print. Okay, it's general term, understand? Then here you can understand that, let's see, I is equals to 1. Then what will happen? It checks is I is less than 6, then it will print. Okay, one loop is complete. So how much time it will how much operation have happened? Like everything is done in in the code is the operation. So I equals to 1, like one operation, I is less than 6 is second operation, and then print Sweta is third operation. Then what happened? I initialize with 1, like I equals to I plus 1. What is the value of I is now 2, and then it will check. So now the value of I is 2. So another operation have done. Then it will check, is I is less than 6? Yes, I is less than 6. Then second operation. Then what will happen? It will check, then print it. Okay, Swet, third operation. Then what next? Swet, third operation. Then what next? Then again and again, what happened? I initialize, it checks is I is less than 6 or not, then print. So how much time it will take, like how much loop it takes? So this will complete in 5 loop. Okay, in 5 loop. So in every loop we have 3 operation. So what we can do, 1 2. Okay, so generally we can say that there is 15 operation have done. Okay, understand? So but this is not the time complexity. There is some rule for the time complexity, like always calculate time complexity in worst case. Okay, avoid constant value, and third one is avoid lower bound. Okay, so what is always start with? Always calculate in terms of worst case. Okay, so basically there will be 3 cases, like best case, average case, and worst case. Okay, so I'm going to start with with one example. What is age? Okay, you need to put the value of age, and okay, so this is the code. So for best case, let's think like how much age should be where we can't do that much operation. So let's assume like we are taking age equals to 90. Okay, so what is here? If age is greater than 80, yes, age is greater than 80, one operation, then print 30 lpa. Okay, second operation. So this is our best case. Okay, where we only like work on 2 operation. So what is best case for this code is 2. Okay, and let's think age is greater equals to 30. So what will happen if age is greater than or equal to 80? No, so one operation. Next, if age is greater than or equal to 60 and age is less than 80, so is it true? No, second operation. If age is greater than or equal to 24 and age is less than 60, is it true? No, so this is our third operation. If age is greater than or equal to 18 or age is less than 24, no, so this is our fourth operation. And else if this all not is true, then what? Print not earning. So what in worst case we have 5 operation. Okay, so for average case, you can understand, you can say like best case plus worst case divided by 2 is our average case. Okay, so let's think why we always calculate in terms of worst case. Let's think like you build a model. Okay, you build a model. This is our model, and we have only like what you have two options only. Like what you can do, you can take only 100 data from the user, okay, to run your to like train your model, or you can take millions of data. So what should be great for your model? It is always millions of data, okay. So for that we only think about in worst case. Like if any model works on worst case, then it always works on best case. For another example, let's think like you are a developer and you are making a website, okay, and you have two options. You are going to make a website for 100 users, and you are going to, or you can make you website for like 1 CR, okay, 1 crore of user. So what is worst case? Like 1 CR, if your your website will run in like 1 CR of users, then your code always run or smoothly in 100 users, okay. So why? So now I think you guys understand like why we always calculate in worst case, okay. So another thing is, so our next rule is avoid the constant value and avoid the lower bound. For that, let's assume like we have a code, okay, and the time complexity for that code is like 5n to the power 6 plus 2n to the power 2 plus like 10, okay. So let's assume n is equals to 10 to the power 10, okay. So what will be the value of like 5 into and like 10 to the power 60, 6 to 10, 60 plus 2 into 10 to the power 20 plus 10. So let's think like that you have that much, like that much 10 to the power 60 values, okay, like that much zero after, okay. And what happened if you add plus 10 in this? That makes sense? No. That's why we don't need to use constant value in our like time complexity. So what we can do, we always use like we always avoid the constant value in the given time complexity for any code, okay. And for that and let's think like 10 to the power 20 value, okay. This is like 60, and your and let's think you have 10 to the power 20, okay, like that much only, 1 and 20 0 and 1 and 60 0. What you think if you will add that much amount of in like that small number, that makes sense? No, it will not make sense, because it is not affected by this. So that's why we are not we always avoid lower bound, okay. So what is the time complexity for this is like 5 into n to the power 6, okay. And here also we don't like we don't need 5. Why? Let's think like you have a time complexity like 3n, okay, and this a linear, a line, it makes a line, and if you remove 3, then always it make only line only, not anything, okay. So that's why we don't need to use like 5. So what is our time complexity is order of n to the power 6, okay. So thank you everyone. We have learned time complexity, and for different types of time complexity we will learn and discuss in next video. So thank you everyone, thank you very much for watching this video.